The debate continues to move through the what is the sphere that we're in now anyway, into the AI sphere even now. The debate about whether, in fact, autonomous vehicles, AVs, absolutely require, must have some additional things besides eight eyes. And that one thing that most people think it needs is LiDAR, because after all, those eight eyes can't see as well in the rain or the fog, or they can't see seven cars ahead. I heard one pundit put it the other day. Well, I have a honest to goodness engineer on today because that certainly isn't what I am. So Phil Beisel, who has been an engineer at Apple, no less, and a C-level guy at I believe that's correct. If I tell me if I'm wrong, in the world of Rivian, is here back again.
Below sea level,
Below, just below sea level, just
where real work gets done.
below sea level. So this would be like in the Dead Sea or
Yeah, yeah, below sea level.
below sea level.
Yeah, yeah. Too funny. Too
Well,
funny.
okay, Phil. Thanks for coming back, and I understand that you've been having a little bit of a debate online this week about this thing that is really, in my mind, has been a decided issue because if Elon says it, I generally speaking just accept it. But that's because I don't have any engineering background. So, start us off. Where does the argument sit in your opinion right now?
Well, I mean, it's. I think it's the argument that will continue to persist because it's the thing you can hang around someone's neck with no sense of evidence, or you can just say it infinitely. Um, but I think it's good to start to dispel why lidar doesn't really solve the problems people think it does. I mean, there's really kind of I think a couple camps of people here. There's those who know nothing about it at all and just assume it's the God sensor, right? They say this sensor is the God sensor, and by having this sensor, all problems would be solved. They have no engineering background. They don't even know what it does, um, and that's an argument that's never worth having because it it's like arguing politics. And then there's a bunch of folks that actually have some knowledge of lidar and may even have some engineering experience with lidar or are from the industry, the manufacturers or subsequent industries built around lidar, who are proponents of lidar and see it as the God sensor. So, but it really adds a lot of complexity. And the way I look at it is there's really two elements of this. One, I want to talk about the whole engineering process, which I think is a lot more interesting because it really colors what it takes to put something like that in a system.
Hmm.
You don't snap it in and have it happen. But the first part is just sort of the logic of the thing, and the logic of the thing goes as follows. I mean, lidar itself is a light emitting radar system, and so what it does is it sends out light beams, particles, like photons, and looks for reflection off of hard surfaces, and therefore can build a point map of that reality. And it's fast, right? It's super fast, um, but it does have trouble with ice, snow, fog, rain because it emits light, and light gets reflected off of those surfaces. Um, and they call that scatter.
Mm-hmm.
And they've done a lot in the industry to mitigate that in the processing layer, but it's certainly not perfect. So those who argue that it solves the rain problem or the fog problem are completely out of their game. That doesn't make sense. That would be more suitable for an actual radar itself.
Mm-hmm.
Something like we think of traditional radar. Um, and so let's talk a little bit of how Tesla uses lidar because they do. And this is,
So let me just drop back for a minute, just
yeah,
to maybe use an analogy, because again, I'm the dummy here. This is like having Brian Wang on, where I just sit here and try to become the fool in the room who might have an idea.
yeah, he's
So
pretty great.
I have driven in fog that you could not see past your hood.
Yeah.
In fact, so bad one time in upstate New York that I had to open my car door so I could see the curb so I could pull over. That was the kind of fog I was in. That's about the worst I've ever seen. But what I noticed was that it was worse when I had my lights on,
Absolutely. Yeah.
because the light was bouncing back in my face and
Yeah.
blinding. So is that kind of
Yeah, it's exactly, that's really it. I mean, the professional drivers, people that know, will tell you don't use your high beams in fog for that reason.
Mhm.
So it's better to see through it without any reflective aspect of it. So yeah, it's the same thing.
Okay, all right.
It's just that the sensor's receiving that data, and um, it's going to get some kind of scatter off of it. We get kind of just a blot out
Mhm.
effect, oversaturation to our eyes from the light reflection. And I'd say probably the LiDAR in a sense is getting the same thing, although I'm not specifically a LiDAR
Okay.
expert. Yeah. Um, yeah.
Okay. So then
So,
this is a misnomer to a certain extent, that it actually does better in fog and rain. So that would be point number one, is that maybe it just doesn't do better anyway.
yeah, I mean, let's talk about how Tesla uses LiDAR, because Tesla uses LiDAR.
Yeah.
And this is a really, really important point here, is that they've got a patent on this. I reference it in the post that I put up this weekend or this week. And I think it's from 2018, but I think it's still quite pertinent. What they're doing is they're using LiDAR in let's call it the training phase.
Mhm.
I'll just call it the data gathering phase or data training phase. And essentially what they're using it for is um, called an alternate ground truth. So
Mhm.
they're taking the vision, and they're using the vision to through referential frames to create the idea of distance to objects and so forth, much like we do as humans.
Sure.
Um, but then they're trying to create some ground truth themselves. And so just to point it out, is LiDAR itself isn't the ground truth, but it is another grounded element that you can then calibrate off of. So in a sense, if you think about it, to say what Tesla's doing is they're factoring out of the LiDAR out of the production system by
Mhm.
including it in the training side of the equation. So essentially, it is part of this solution, just not how everyone envisions it. They are able to then make the vision system highly calibrated and sensitive to object detection and dynamic object detection, meaning not just the detection of the object, but its motion,
Uh-huh.
like another car or a person, by using LiDAR in the early stage. And that's why you see Tesla vehicles with LiDARs on them, because they're part of that, creating that calibration set. So once you've done that, now, this process is to factor it out, to take it out of the production system. So now you've subtracted it out. It's like the best of both worlds, really. You've used it, and I think they're using it less and less, or they may drift back to it from time to time. But because their vision, I think, has gotten so good at this that the calibration isn't as necessary. And so you've got the best of both worlds. You've got the potentiality, the good parts of LiDAR being utilized in the early stages to essentially create the trained AI, the parameterization of how the car is going to drive with a vision only system.
Nice.
And yeah, that's their breakthrough. And I mean, there's so much more. Obviously, we've talked about it a lot. I've done articles on FSD, but this isn't the heart of FSD, but it is how we should think about LiDAR and FSD.
So when they're going right now into the across the river, so to speak, into the rest of Austin, and they've got
Mm.
these vehicles that are outfitted with all this equipment, is that what they're doing, or are they
Well,
actually doing some mapping, or do you know what they're doing?
I specifically, I do not know what they're doing, so it's important to say that. But I have not, I'm not on the ground, and then I can't look at
Right.
those towers specifically. They could have these low profile lidars in them,
Mhm.
um, kind of downsized versions, or it's possible that they're just vision systems.
Mhm.
But I would argue that what they're doing is, yes, they are mapping a specific space. They've a specific roadway to calibrate.
Mhm.
So we're back to the calibration idea that says, okay, if our FSD is to, in say, running in a verifying, simulating operation, look at a circumstance, we have something to run a ground truth against.
Not, mhm.
Yeah. Otherwise, it's just, it's just how it operates in the field. And if you want uh, a highly safe system, which they do, you're going to want to have some certainty, going in. So I think I think what's happened here, and people say, well, oh, I see what they're doing. They're mapping out all of Austin, much like Waymo maps out San Francisco. No, that is not what's happening. It is why in Austin? Well, Austin has become ground zero for their autonomy program at this point. So why the heck wouldn't you be in Austin? I mean, I've seen the same vehicles in Palo Alto, and I could probably find one today if I roam around.
Mm.
And of course, but all eyes are on Austin, so you'll see them
Right.
in all the videos. But the point is, I suspect there are a lot there because Tesla knows that city very well now. It's been, I mean, before they released Robotaxi in the wild, they had Project Rodeo, right, which was their own internal testing program, and they're just continuing that program in parallel. And now they have real customer data. They're getting some scale out of that, and they're probably just re-verifying, recalibrating their system on a constant basis, I think.
So would you expect this also to be something that can be used less and less as
Yeah.
we move out across the country and the world?
Yeah. I mean, what is FSD? It is a general purpose driving system that drop a vehicle into any roadway anywhere in the world, and it can drive just like you and me. Um, but at that, but to get there, it needed a lot of yous and me's, and which is the data side, right? It needed a lot of data and good data. The key is good data. It's not just data.
Mhm.
If we train FSD on all data, we might end up with the same number of highway deaths we have now. Because, truth be told, the average human driver is absolutely terrible at driving.
Right.
So what Tesla has always done is cherry pick the very best data, and they have technique and process to pick that very good data from either.
So, yeah. So taking a little bit of a rabbit trail just for a second, I think that's super interesting because Tom Lee, this morning, the
Mhm.
investment guru, he was on a program last week in Korea where he's on a question and answers series, and he was talking about AI and how he's using AI in his own office. And he says the one place that we're not using AI is for making investment decisions. He says, because the information that's coming in is all information. Therefore, it's good and bad. It's every kind of information. And so we can't trust that information. And then we had Elon last week saying that he, for XAI, is now going to rewrite the corpus of all information because of the same thing. So it looks to me like he's doing it based on what you've just told me. It looks to me like he's going to take that same principle that he used for vision and now apply it to LLMs.
Yeah, I think it's the old adage in engineering is, garbage in, garbage
Right.
out. So if you train a system on terrible data or erroneous data, you get erroneous answers. I mean, how could you get something else?
Right.
It's almost, it's a
Right.
self-fulfilling prophecy.
Right.
So in the case of FSD, the key is to your point, is to not only cherry pick the very best driving behaviors, the ones that um, you know get get through the zone,
Mhm.
the roadway segment with no collisions, accidents, or other types of aberrant behavior. So that's the type of process that Tesla has honed in on, good data selection. And now, a little bit to your point, is Tesla's also built, probably, I shouldn't say probably, knowingly, they built an amazing world-class data simulator.
Yeah.
So when they build a piece of driving data in the simulator and then they use that piece of data for training, I guarantee that that piece of data that they're training on is perfect driving behavior.
Yes.
And when I say perfect, it is not just from a safety equation, but it is from a fluidity kind of human. If you notice, uh, Waymos are very choppy and have a lot of jitter in the system. There's a couple reasons for that. Uh, the other reasons would be their algorithmically based kind of driving solutions, and they have latency problems to their controls because they don't. Waymo doesn't control the whole hardware package. They're not a vertically integrated company. But besides that, um, they're not. If you take that algorithmic approach, it's not how a human drives. It's how we pull back the decisions in driving, and that's not going to lead to fluid, smooth driving. Like I saw, and I don't know why this happened. And I was driving on FST the other day, and I was on a highway where there was literally no other vehicles, and it made a lane change without the blinker. And I was really wondering, yeah, and I was really wondering, did it do that because of trained data, or did it do that because it's, well, in some sense, a bug?
Yeah. Yeah.
And I don't know, actually don't know the answer. I don't know the answer, but I'm using it as an example just to point out that as a human, it would be kind of really weird to put on blinker on if there was literally no one on the highway.
Right.
I mean, there are humans that will stop at a red light at 3 a.m. at an intersection that no one's going to be at for 4 more hours.
Yeah.
But most humans will run that red light because it's just kind of categorically insane to stop, right? Um, so I think that that's the advantage of training on good driving behavior and having it properly calibrated, even using a lidar to help the calibration process.
All right. So after going all down all kinds of rabbit holes, but I think they were super interesting rabbit holes, let's pull back to the LiDAR story because I know that you have more to talk about on that.
Yeah, so I really want to talk a bit about the engineering process,
Sure.
because this is a part of the story that I think is missed. And the armchair engineer, or the pundit at large, will claim that you just snap your finger, add a sensor, the engineering process isn't any more complicated, and you have lidar in the system. So they think in their minds, well, why, except for the cost,
Mhm.
why wouldn't you just snap your fingers and add a lidar? It would make the system safer, wouldn't it? It would, right? And of course, the opposite is quite true in my opinion, and a lot of that has to do with the process itself, the engineering process. And I put up a post, and it was kind of funny. I learned this over and over through engineering over my entire career. Meaning I've never learned it well enough, which makes me a fool. But there's this KISS principle: keep it simple, stupid, right? And I remember way back in I had a robotics class in college, and the professor first day didn't know him, funny guy, but he just came up on the board in chalk, big board, 4 panels, and wrote KISS on each panel. And he said, and I think he was basically saying this is a theme of the class: robotics is going to be hard, and you should really focus in on simple solutions. And just to beg the audience's attention for a moment, the story that kind of cemented in my brain, and I've never forgotten, was the project that he gave us right after that. And the project was that we had these little robots, and the first assignment had nothing to do with moving them at all. It just had to do with having two robots communicate to each other. I mean, you could have used computers; you didn't need the robots, but and you had some controls on the speaker. You could generate any kind of frequency at any duration, and then you had some control on the input microphone, And the real goal of this was he would give you a sentence you've never seen before, and your job was to communicate it accurately as possible to the other robot as quickly as possible. So first order goal as accurately as possible, second order goal as quickly as possible. And he made it a contest, and he wanted to see who would have the highest percent of accuracy, lowest communication, highest bandwidth communication. And and I luckily paired with my incredibly smart roommate, and he literally, I'm ready to go jump in and start doing crazy stuff, and he literally looks at me and he goes, "Well, how did the class start? We started with the KISS principle, so let's do that." And we thought hard about it for, I would say, 10 minutes, like what would be the simplest way to do it. And we said, you know what? Let's just use Morse code. Let's just use Morse code because we don't have to mess with the frequency variance. You know, we just have to have short and long tones. And what we did is we coded that up, and it took us like literally a half an hour. And then we spent the next hour and a half or so just writing a loop to compress the short and long tones, right, ratably, and come up with the smallest. And so when the robot spoke, it spoke at an incredibly high rate. You couldn't determine it was Morse code, but if you slowed it down, it would be obvious. And our entire project took us 2 hours, and I swear to you that most teams were in the lab, burning the midnight oil for 2 weeks trying to get in their encoded scheme working. And I never forgot that
Yeah.
lesson.
Yeah, no, but you said you did. And,
Well,
and by the way, you're in good company because Elon says that he has his 5 levels,
yep,
that he
yep.
always is forgetting them and always having to remember level number
Well,
2 or number 4.
you're right, Randy. I have forgotten it from time to time, and it is one of those things where you have to remind yourself. It's like a
Right.
discipline. It's like a discipline saying, if you eat fewer calories, you will lose weight. But I mean, yeah, the KISS principle really is all over Elon's stuff. Delete, delete, delete.
Yep.
Make requirements less dumb. The best part is no part. I mean, that's a good example. Why would you?
Don't automate until you have it.
Yeah, I mean, think about the LiDAR debate. The best part is no part.
Right.
Well, maybe the best part is no part. And I think that's so I think that process, if you're really honed in and you're trying to create the simplest thing that solves the problem, you tried to use the least number of sensors in the system. And I think that's and I'm sure they made their mistakes, meaning you would forget those principles and you would go to these heavyweight solutions. But I think here's some points about the engineering process that I think tells a story on why including LiDAR isn't just a snap your fingers type of thing. Um, when you're trying to add a system like that, it's usually a novel system to an engineering organization that potentially isn't used to sensors are specialized entities. So what you tend to do is you tend to go out and hire one or more SMEs, subject matter experts in LiDAR. And unfortunately, I mean, that seems like a great idea. Go get somebody who really understands it. But unfortunately, what that tends to lead to is this sort of this person tends to build out an organization based on that, and then they dig in on self-preservation.
Right.
Right. So it's a human quality. I mean, we wouldn't want to axe ourselves.
Right.
So it's very hard for the
Okay.
yeah. I mean, it's like the LiDAR expert doesn't go into the meeting and saying, "I think LiDAR is stupid." Um, that rarely happens. But so a classic engineering organization. When I say classic, I mean somewhat in a negative sense, would allow those sub organizations to build themselves into some kind of towers of specialization, and therefore self-preservation and and a whole bunch of other interesting nightmares. And if you wanted to use LiDAR in a system, you thought it was the right thing to do, what you would do is you would be very careful on how you selected your subject matter expert or experts. You would be looking for people that are very open-minded engineers and just happen to be incredibly smart. So, smart over expert, not somebody that leads with their resume, somebody is kind of open. I mean, often, how does an expert become an expert anyway? Uh, they just learn a system, right? Either because they were taught something from a mentor, whether it's formalized, in teaching or just in your engineering processes. So, in a sense, smart people learn great things. And what you would better organization style is to take the people who know LiDAR and just embed them in the sensor team. So there's only one sensor team,
Right.
and therefore they're all unified in their goals, and nobody, has to be the winner.
Right.
The system has to be the winner, and I think that's a way to do that better. But so now, if you take another sensor into the system outside, so let's say you have vision or just LiDAR, and you're trying to add the other, now you've got the problem of fusion, right? And you've got to fuse the data together from these sensors, and you usually will pick a strategy: early or late fusion. So early fusion is the idea that you just take the raw data without trying to derive essentially meaning from the data, and you just kind of use it with the raw data from the other sensor, and you're fusing the data early in the pipeline, kind of like the decision pipeline. Late fusion is where you let the subsystem, the sensor, uh, derive its reality. In other words, its answer,
Mhm.
and you fuse the answers together, if you
Mm.
will. So like late fusion would be more like, I see a car at 20 meters ahead going 10 meters a second at this direction, whereas early fusion would be just the raw object data. So now, as an engineering organization, you're going to have to make this choice: go early, go late. There's pros and cons. You can rabbit hole on early and decide you want late, too late in the game. You can rabbit hole on late, decide early is a better strategy. Um, and all this is extra complexity. I mean, not just a little, by the way. Like, we're talking about what takes up 90% of your day are these questions. So you started with this simplistic, I've got a sensor, I've got a sensor. Now you've got this problem of determining which sensor's correct, which sensor has the best data. Is it situational? Like, for example, if you knew that the LiDAR system you had, the way you've oriented it, was really bad in rain, do you deprioritize its input when exactly it's raining and then reprioritize it when it's not? So these are incredibly detailed levels of decisions that you don't have to make if you don't have the problem in the first place.
Okay, so let's drop back real quick because it just for the very first time occurred to me as you're telling me this. So why isn't that also a problem with eight eyes? So there's overlap of
Sure.
what the different cameras are
Yeah.
seeing, and there's going to be different refraction, reflection,
Yeah. It is.
different all kinds of things.
No,
So
it is. It
okay,
is. It's just that it is. It's just that somebody has said, well, it's better to have a field of view of 360 degrees by virtue of eight cameras than it has better than to have 120 degrees on one or two cameras, like
right.
human eyes. So yeah, that problem is there. It's just that how many of these problems do you want to
I
tackle?
see. So this is like adding just one more problem.
Yeah, I mean,
So
you're absolutely right. If you've ever seen, just to simplify it, if you've ever seen these 3D overhead views, like in my Rivian has this incredible overhead view of the
oh
car.
yeah, yeah,
That's a fusion of the cameras,
yeah,
and you see that readily when you open the door of one of the. You see, whoa, it distorts it, but
yeah.
otherwise, it looks like you literally have a drone overhead, and it's beautiful and it's perfect. And they've had to build that fusion algorithm, right? So yes, you do have that problem, Randy. It's just how many more problems like that do you want to have, especially if you're adding another modality? Because if you have eight cameras, there's still cameras, and
Right,
all the input data is of the same
right.
classification and category and frequency and so forth. If you're moving into LiDAR, now you've got a completely different kind of data set.
Right.
So the other interesting thing about LiDAR is that when you bring it in to your organization, a good engineering organization, just like the camera, will want to strip back to literally the photon, or they'll basically want to, like, the vendor will produce a system if it's sourced from a vendor. They'll want to produce a system that kind of is a coded system that interprets the data and gives their idea of people familiar with Mobileye in camera space understand this. It's like they want to add value as a vendor, because if it was just stripped down to no value, then you could swap vendors quite readily, right? So one of the problems you have when you source something like this is you're fighting with the vendor
Mm,
in a pretty serious kind of way, to kind of suggest to the vendor you don't want their code.
mm,
You guys, we are capable as an engineering organization to go at the raw data,
mm,
and that's a fight they don't want to give in, because they've got lock-in
mhm.
if you use their APIs. And so, especially with a LiDAR system, like you may think, oh, that's true of cameras as well, but it's much less so, because the cameras are so, it's almost like a horizontal technology at this point,
Mhm.
right? I mean, obviously, Tesla's using some pretty special kinds of ways of getting those photons in, and that are not like human vision spectrum kind of
Sure.
stuff. But LiDAR is a whole different thing. It's an industry by very specific vendors who want to protect that industry, and so they're going to give you the system. And then what happens is, if you fail to get past their APIs and get down to the hardware layer, then you're going to be rabbit holing on a build versus buy. You're going to be saying, why don't we just go build our own? Um, and capable engineering organizations can in fact build their own. I mean,
Sure.
but because if we don't build our own, we lose control. You know,
Now you,
so
now you have the scale issue, because how are you going to scale it?
right,
So you're going to, instead of having something that gives you an advantage of vertical manufacturing, you have a disadvantage, because your scaling potential is magnitudes more difficult.
yeah, so after all this, by taking another sensor and one as complex as LiDAR into the system, you now got an extremely complex system that has essentially has reduced your ability for velocity of change, because it's now hard to verify the system. You don't know what piece is not performing well, and as you revise it, so you're trying to, obviously these software hardware systems are revised infinitely to achieve better results,
Right.
better performance, whether that's
Right.
safety performance metrics or driving fluidity, et cetera. And so every change you make uh, is a change to the whole system, or maybe a change to the whole system. So you don't really know, what you need to tweak. So you've got a very complex system, which reduces your ability to change it. Kind of, you're afraid to change it to a
Yeah.
certain
Yeah.
respect.
Yeah.
Or if you do change it, you're not sure what change had the effect or good or bad.
Mhm.
Um, and it leads to a fragile system, and both things are really bad for safety, right? Because imagine that you built this in your mind, perfect LiDAR uh, camera based uh, driving system, autonomous driving system, and you put it out there and you encounter problems.
Mhm.
And these problems are really bad problems, and they're edge cases, but doesn't matter, right? They're causing injury or accident, and now you've got to go back in and you've got to fix this problem, and so you've got to verify it. You've got to try to break through all these layers and try to figure out who's causing the issue. So you have a
Mhm.
much larger debugging and testing problem. And then because of all that, your ability to change it uh, rapidly is diminished. So now you've got a system in the field that is potentially dangerous, and you can't turn around and just fix it quickly. So this is engineering reality versus this almost comedic in my view of how you add a sensor, like snap your fingers, put in the God sensor, it solves the problem. I mean, um, that's not engineering 101. It's not how it happens on the ground. Um, and believe me, it's not how it happens.
So I have no formal engineering training, but I do have practical engineering training, having run a plastics manufacturing plant for almost 30 years. One of the things that we, talked about frequently was over engineering.
Hmm.
And one of the issues with regard to over engineering was always what is going to be the advantage? How much better will we be if we do this next step, if we add this next layer of some kind of automation or some kind of equipment that's going to make it a little faster or make it a little higher quality control? How much advantage are we really going to get? And this is the issue that I thought of last week, actually, before I even know you were going to talk about this today, was when Jim Farley says, "Oh, I still think that we need to get lidar on this car." I'm thinking to myself, it's ugly, it's expensive. So what kind of advantage am I going to get by adding an ugly, expensive thing? Because those are pretty big disadvantages to this next layer of engineering. And so my thought was, well, let's say that the expected level of FSD by the end of this year will reduce accidents and injuries and deaths by 50%. Will LiDAR potentially reduce it by another 50%, or will it be 10%, or will it be 3%? And so unless I have some kind of an ability to kind of speculate wisely about the additional safety advantage, why would I want to have that extra expense? And as to your point, the extra complexity as well as the ugly darn thing on the top of the car.
Yeah. Well, for people who didn't see that video, it's Jim Farley, right, Jim?
Right, Jim.
CEO of Ford. Honestly made a complete buffoon of himself. It was actually hard to watch. And I cannot believe he's a CEO of a major corporation that is heading directly on a collision course with technology. Part of his argument was that humans are better drivers than machines, and humans are able to master this skill. So what knocks that argument right to the ground is the fact that there's still 40,000 deaths on the highways every year. So if we are able as humans to master the skill, why have we not mastered it in 100 years? Okay.
And we're no longer driving elevators, airplanes, or trains.
Right. Right. Exactly. So, that it's a crazy, that was a crazy argument he made it. And you have to believe he could not have genuinely thought that to be true. Um, and it's just a crazy thought. And in fact, it also is a counter argument to the idea that like FSD is a great system, because in what he's saying is, oh, humans are apparently able to master these skills, but if we used human data to train a system, somehow that wouldn't be mastery. That's crazy. And so it seems to me that he either doesn't know what he's talking about, or he's trying to shape the conversation,
Uh,
which in simple terms, that's called lying.
right.
And or in engineering, base it out in engineering, it's called lying. So like, right. I mean, it's crazy to see him take this position. I mean, I ask myself, who's he fooling?
Yeah.
Maybe the next Ford buyer that's been a loyal Ford buyer, kind of believes him. And but anybody looking at that through the lens of where technology's going and the fact that autonomy will be part of our lives in driving, in fact, will probably take over. I mean, he does discuss the pleasure of driving argument, which is fair. By the way, that's a completely fair thing. There's a pleasure in riding horses.
Right.
There's a pleasure in operating an airplane. Most private pilots are usually people that just enjoy the craft. There's a pleasure making your own espresso. Um, there's a complexity in it and a sense of accomplishment. So all those things are true, but they're not why we drive. And I would say I made this argument in a pitch on that. I said, just replace driving with dishwashing and see how well his argument holds up, right? The fact that, you would say that there's such a great pleasure in washing your own dishes. Some people say that it's therapeutic. But you have to listen to him and just kind of marvel at the conflicting logic and wonder where Ford really is. And I mean, I obviously I have a bit of experience this because when I was at Rivian, we did an early deal with Ford. Ford
Mm.
funded $500 million to Rivian equity, and we had a non-specified project that we would work on together. And there's a lot to the story, and a lot of the story I would not tell because I just don't talk about former inside baseball stuff. Um, but I think that the sudden reality for me was when I sat in a room with 15 of their brightest and best, which were really nice, wonderful humans, like great people. Um, but they just literally, from a tech perspective, did not get it.
Wow.
Did not get it. And if the lead off for every one of them when they talked about their domains is how many years they spent at Ford and what they had done. And most of the stuff was not in tech. Nobody came from the tech field directly. Nobody was a Silicon Valley resident. Not that that's the
Right, I
end
understand.
state,
I get you.
but it just shows this difference, and it's hard working with them because they have language of their own. They have processes that are very antiquated, and therefore you could see why a company like Ford would choose Lidar because they're used to these layered systems. They're used to sourcing from vendors who tell them
Yeah,
what the ground truth is.
yeah, yeah.
So if you've got a very convincing sales department from Lidar vendor A, um, and you've got someone who doesn't understand that field or is just a project manager, in other words, someone that doesn't understand the technology at its most fundamental level, they're going to pitch that up the executive rank. And I guarantee that the most knowledgeable person is not pitching the CEO at a company like Ford. It's many, many management layers removed. So it's still down to a PowerPoint at the end with the person pitching to the CEO. It has no actual knowledge of the system himself.
So
Um,
then if I'm the buyer or if I'm the rep, either one, and I've been in that role on both sides most of my life as either the rep or the buyer, I'm going to say, well, look, Google's still using Waymo. I mean,
right.
Google
I must agree.
Waymo is still using LiDAR.
Yeah.
And they got their Silicon Valley. These guys are, first principles guys. And if they're still using LiDAR, there must be a reason. And that would be my pitch.
Yeah. No, that's a suitable pitch, and there are so many others too. But I think if we're somewhat topically different here, I think that legacy auto is quite cooked.
Quite,
It's
quite
this.
cooked.
Yeah, and this is not um, that I don't think they can shape themselves as a company that's going to be tech forward. I mean, it's almost ridiculously obvious.
Yeah, I don't know if you and I have talked about this yet. I talked about it on my show about 10 days, maybe it was 2 weeks ago now, that I had this moment when I was trying to reproject the switch from ICE cars to electric cars because I've had these charts for 3 years showing that by 2028 it was going to be almost 100% elimination of ICE and electric, and all of a sudden that slowed down dramatically in terms of the curve. And then we have this switch over now to AV, and the light went on, and I go, it's not gonna be EV versus ICE. It's going to be AV versus all vehicles.
Right.
So
And all AVs will be electric.
and all the AVs will be electric.
Yeah.
And doing that projection, it seemed to me that we will have something on the order of 5 million AVs produced in say 2027, maybe more, maybe 2020, or maybe it's 2028 before we get to 5 million. But the real ratio of replacement of ICE cars that don't have AV is 7-1. Elon always talks 5-1, but I've done the math 15 times, and there's no way that a fully operational AV doesn't get 7 times as much hours on the road and 7 times as many miles
Sure.
as a
Right.
So 7 times 5 million is 35 million ICE cars that won't be sold that year.
Right. Yeah. I mean,
Pretty much the end. That's
yeah, it's a bit like saying, I had this thing called a landline phone, and I'm going to replace it with a cellular phone, and then the iPhone comes along and swamps both of them, really,
Yeah.
in the end. And I think that's what we'll have with autonomous. It's autonomous kind of. It's really interesting, Randy. When you start both at Rivian and Tesla, you start at the high end and you chip lower
Yeah.
for your, and it makes complete sense. There's the logic of that makes a lot of sense. And Tesla's probably about to chip lower with some new models. But you think about it, what's happening, what happened, I wouldn't say first with autonomous, but it allows the lowest end purchaser not to purchase at all.
Right.
Yeah. So now we have a circumstance where if the cost per mile is demonstrably lower than the cost of mile of ownership, which it is for the amount of movement, unless it's extreme, now you're going to switch into the autonomous. And so by virtue of the number of miles, autonomous is going to start to take over. And since it's all built on, all of autonomous is built on electric platforms, the adoption of, depending, if you say cars on the road as opposed to consumer purchased cars, the cars on the road demonstrably will be EVs. And in this particular case, I think they'll mostly be Tesla Cybercabs and Model Ys running Robotech.
I think you're 100% right. So I have distracted you once again from the LiDAR story. Did you get all of your points in, because they were all great? I enjoyed every minute of it. Is there anything that we left out?
No, not really. I think we hammered home, the two key areas here are, look at how Tesla uses LiDAR and look at it as a system for doing fundamental calibration and essentially factoring it out of the production system. Basically, all of what you see and how their algorithmic, I should say, the AI, the model runs, has already included LiDAR, but in a very different way than most people assume. It's done it early in the process. And then I would say, secondly, there is no way that their scale out game includes mapping out areas with LiDAR. That is not happening.
Right.
For all the reasons I mentioned. But that doesn't mean that they won't be heavily mapping at some level and gathering data at some level in Austin, because why wouldn't you? At this point, you know the city so well. And then the rest of the argument is really about understanding the complexities in the engineering process, both, not just technical complexity, but organizational complexity, which, is something that people don't think of enough in these kinds of situations. And for all those reasons, if you go back to that KISS principle or Elon's engineering principles, you should ask yourself at the very early stage, do I need this thing?
Right.
Do I need this thing? And the reason, to kind of go full circle, that you don't get that from Ford is because leadership there is not technical and is not leadership.
Right.
I mean, I hate to say it that way, but there are companies like Tesla and my former employer Rivian with the CEO RJ, who make fun. They are technically minded founders. They run their companies and they make decisions that are fun. They make decisions and they can cut through and say, well, I'm sorry you built up a LiDAR organization of over 50 subject matter experts, but we will be killing it tomorrow.
Right. It's over. Yeah.
Yeah. Yeah, we're going to take the smart guys and incorporate them that are willing to learn something different, and it's over. And that just doesn't happen at a Ford, and unfortunately never will. So,
Well, I have to say that you said in the green room, and then you said at the outset that you were going to put the final nail in the coffin of LiDAR. And I kind of I had trepidation. I was like, that might be overselling what you're going to accomplish. But I got to say, for me, and I'd love to hear in the comments below for everybody else, I think that Phil put the final. I think the nail has been driven and has been accomplished. That was a no wonder you got so much activity on X out of that article that you put up. That was extremely well said. So as always, Phil Beisel, thank you for coming on and helping us once again to get, I think, closer to what would you call it, for those of us who don't have the engineering training, a much better look at what the engineering problem is with LiDAR. Thanks again. And to all of you out there, it has been, as always, great talking to you.